Welcome to our podcast. Today we're diving into the fascinating world of mycelium, a powerful framework that's changing how we think about data transfer and storage. So let's get started. Have you ever wondered how your data moves around behind the scenes? We send messages, share files, but what actually happens? Well, mycelium is a set of typed formats designed for just this purpose. It can handle everything from simple bits and arrays to more complex structures like products, sums, and even lists. But what's really intriguing is that it also supports some more nuanced concepts like refs, expressions, and even functions or procedures. And here's a fun thought. Imagine if every piece of data you interacted with had a type. In mycelium, that's not just an idea, it's a fundamental aspect of how values are defined. Each value is not just a set of numbers or characters, but a defined entity based on its type. This means you can store anything from a simple number all the way to a complex data structure, and you can also transfer these data types seamlessly. Now, what really stands out is the mycelium virtual machine, or MVM for short. Think of it as an abstract machine that takes care of evaluating mycelium expressions. What's unique about the MVM is that every value is immutable. For those who might not be familiar, immutability means that once the values are created, they cannot be changed. This can lead to more predictable and safer computing, especially in multi-threaded environments. Oh, and MVM has a few tricks up its sleeve when it comes to inter-process communication. It uses operations like input, output, and interact on special values called ports. These are the points where the action happens. And here's a little tech nugget for you. Since these values are fingerprinted quickly, it allows for some fascinating optimizations. For example, while the MVM doesn't have a dedicated addition operation, it cleverly accelerates addition by leveraging the hardware's native capabilities. Isn't that clever? It's like having a smart assistant that knows to fetch the quickest route instead of taking the long road every time. Next up is mycweb, a format designed to encode mycelium values into a single file for easier management. Imagine carrying a suitcase that can compress all your belongings into one neat package. Even though a mycweb file can only hold one mycelium value, the catch is that this value can itself encapsulate complex structures like arrays or products that bring along their own contents. Let's move on to the Mycelium Network Protocol, or MNP. This is where it gets really interesting. MNP is a peer-to-peer protocol built on QUIC, which is a fast transport layer protocol. It supports sending mycelium values across the network with a neat ask-and-tell semantics that ensures that all communications are authenticated. And get this, it caches values so that once a type is sent over the network, it doesn't need to be sent again. So, it's intelligent about data transfer, like a good friend who remembers your favorite pizza order. And you might be picturing a new kind of programming language in all of this, right? Enter Spore. It's designed to target the MVM while focusing on a data-oriented syntax, making it easier for developers to create mycelium values that are human-readable. Imagine a language that's as simple as writing your shopping list, yet powerful enough to govern interactions. As we wrap up today's discussion, one of the key takeaways is the emphasis on how mycelium structures our interaction with data. It's about creating a more efficient, immutable, and expressive way to handle the vast amounts of information we juggle every day. Before we finish, I want to leave you with this thought. As the digital world evolves, how might frameworks like mycelium help us redefine our relationship with data in a more sustainable way? Thanks for sticking with us today. We hope you found this exploration